My name is Chaitanya Krishna. I'm from section ITA and my roll number is 19. The practical aspect of object-oriented programming. Object-oriented programming refers to a programming methodology based on objects instead of just functions and procedures. These objects are organized into classes which allow individual objects to be grouped together. Most modern programming languages including Java, C, C++, and PHP are object-oriented languages, and many older programming languages now have object-oriented versions. One of the principal advantages of object-oriented programming techniques over the traditional procedural programming techniques is that they enable programs to create modules that do not need to be changed when a new type of object is added. Here are the basic concepts of object-oriented programming. Object. This is the basic unit of object-oriented programming. That is, both data and function that operate on data are bundled as a unit and are called as objects. Class. When you define a class, you define a blueprint for an object. This doesn't actually define any data, but it does define what the class name means. That is, what an object of the class will consist and of what operations can be performed on such an object. An abstraction. Data abstraction refers to providing only essential information to the outside world and hiding their background details. That is to represent the needed information in program without presenting the details. For example, a database system hides certain details of how data is stored and created and maintained. Similar way, Java classes provide different methods to the outside world without giving internal detail about those methods and data. Encapsulation. Encapsulation is placing the data and the functions that work on that data in the same place. While working with procedural language, it is not always clear which functions work on which variables, but object-oriented programming provides you the framework to place the data and the relevant functions together in the same object. Inheritance. One of the most useful aspects of object-oriented programming is code reusability. As the name suggests, inheritance is the process of forming a new class from an existing class, that is from the existing class called as base class. New class is formed called as derived class. This is a very important concept of object-oriented programming since this feature helps to reduce the code size. Polymorphism. The ability to use an operator or function in different ways, in other words, giving different meaning or functions to the operators or functions, is called polymorphism. Poly refers to many, that is, a single function or an operator functioning in many ways different upon the usage is called polymorphism. Overloading. The concept of overloading is also a branch of polymorphism. When the exiting operator or function is made to operate on new data type, it is said to be overloaded. The advantages of OOPS. OOPS provide a clear modular structure for programs. It is good for defining abstract data types. Implementation details are hidden from other modules, and other modules has a clearly defined interface. It is clear, easy to maintain and modify existing code, as new objects can be created with small difference to existing ones. Objects, methods, instance, message passing, inheritance are some important properties provided by these particular languages. Encapsulation, polymorphism, abstraction are also counts in these fundamentals of programming languages. It implements real-life scenario. In OOPS, the programmer does not define data types but also deals with operations operate for data structures. Performance. Discussing object catching leads to another key practical aspect of object-oriented programming, performance. Performance considerations frequently arise when debating the use of an object-oriented program language. This is particularly true when a language is newly introduced. However, an immature state of implementation should not be confused with the fundamentals of the language. Some project managers tend to believe that the same language mechanisms that encourage clean design and potential reuse, such as class structure, inheritance, and data encapsulation, can also lead to poor performance. They fear that long chains of short function calls tend to occur, which might not lend themselves to code optimization. Dynamic dispatching, as in C++ virtual functions, are also a cause for concern. However, advances in code optimization techniques should alleviate such fears. For example, dynamic compilation in Sun's hotspot technology is expected to outperform even the best optimized procedure code because it optimizes dynamic sequences of function calls. Reusability. In the early days, subclassing was seen as the way to achieve software reusability. However, we quickly learned that classes are a small part of a larger program design, and it is essential to capture and reuse the core elements of program designs. The notion of object frameworks is now the staple of the object-oriented design methodology. While we made significant progress in encouraging code and design reuse, many questions remain. We still need to adequately address practical issues such as how to capture usage patterns and make them accessible to professional programmers. Other fundamental questions include what aspects of a program should be included in a design pattern, and are performance and reliability issues suitable for abstraction description at this level. We might even demand proof of whether frameworks and design patterns really encourage reuse. Many avenues of research are possible when trying to address these questions. Extensibility. Extensibility has been a major promise of object-oriented programming. Today, the state of the art is being delivered on this promise. Extensibility has many facets. It can include support for class inheritance mechanisms, the ability to dynamically load classes, or sophisticated reflection techniques. Software developers have long recognized that they cannot address all of a product's requirements in its first release, and therefore we must be prepared to deal with numerous revisions during the product's lifetime. The majority of changes involve functional extensions. Object-oriented programming offers solutions based on class inheritance and delegation techniques. Both mechanisms have supporters and detractors, and such issues of application modeling are now formally addressed in object-oriented modeling approaches. Java made class loading into a first-class operation, no pun intended. A user can dynamically load an applet into a browser process by simply clicking on a web page containing an applet directive. Indeed, any class can be dynamically loaded into Java runtime. This places enormous power as well as responsibility in the hands of a user because of the security implications. For example, what are the access rights of an applet downloaded from a server? While it is relatively easy to constrain an applet from accessing client's system resources, it is challenging to specify and enforce constraints within the application address space. Distributed objects. Distributed programs are the norm rather than the exception today. Inter-objects messaging and remote procedure calls are an excellent complement to the object-oriented programming style. Because interfaces to objects are well defined, it is easy to think of physically distributing these encapsulated entities among several address spaces and using messages or remote procedure calls for interaction among the objects. Thank you.